So let's think then about how we're going to do this measurement. What I'm going to present here in this chapter is a simple way of doing things which is easily understandable and easily applied to many real-world scenarios. In this chapter, what we'll actually do then is a practical approach, but it's not the most robust or advanced way of doing things. And actually, we will be looking at a more robust framework for benchmarking in the next chapter. So for now, consider the approach that we're going to look at as a quick and dirty measurement system, which is easy to implement, quick to run, and in practical purposes, absolutely sufficient for most scenarios. So let's look at the example then, and you might recall in the last chapter that the profiler told us that one of the methods worthy of potential optimization is our isPrime method. I'm going to go into the project that we had, and the isPrime method I think is in the number checker class. Here it is here. And actually for this chapter, let's create a new project and we'll copy the number checker class into that project. So I hope you're following along with me. So we'll create a new Java project, and I think we'll call this one benchmarking. And then I'd like to copy number checker into my benchmarking project. I think because I'm in Java 11, I'm just going to create a package here first. I'll just call that main. And then I should be able to copy number checker into the main package. So follow along with me. You should now have a project called benchmarking with our number checker in there. And in fact, just to check that works, let's create a runnable main class. And what we'll do in the main class is instantiate our number checker. And then let's just test it. We should be able to do isPrime, and we just need to put in any number which we know will either be prime or not prime. Let's put in 23. That should give us the result true because 23 is a prime number. Let's just print out that to the console. Good, that's true. And we'll just try 22, which isn't prime, and make sure we get a false. Okay, so that's working. I think I'm just going to close my other project so that I'm not confused by what I've got on screen here. So this number checker class then has the isPrime method, and the profiler in the last chapter told us that this method is called an awful lot as part of our application running. So it would be good if we could find a way to optimize this method. Now there are actually two optimizations we can make to this method. The first one is that we are using integer objects here, and if we swap this to use primitives, that could be an optimization that will return some positive results. In fact, you might recall in the last chapter, the profiler was telling us that there's an opportunity to swap objects for primitives to get better performance. And the second optimization is, well, let's imagine we wanted to know, is the number 11 prime? Right now, what this code is doing is running a loop from 2 up to 10 and seeing whether any of those numbers can be divisible into 11. So we're testing in this instance the numbers 2, 3, 4, 5, 6, 7, 8, 9, and 10. Well, the change we can make is that actually we don't have to go all the way up to the number just below the number we're checking. We only need to go as far as this square root of the number. Now, the square root of 11 is 3.36. So actually, it will be sufficient just to test the numbers 2 and 3. If 11 is not divisible by 2 and 3, then it's a prime number. In other words, we can change this loop and shorten the amount of numbers that need to be tested. And it sounds like that should be an optimization worth making. Now, just to be absolutely clear then, I'm going to, I think, change this to say isPrime1, meaning this is version 1 of our isPrime method, and let's create a second version here and call it isPrime2, which will be our potentially optimized version of the method. So rather than our test number being an integer, we're going to use a primitive int, and we can do the same in the loop. So that's the first of our potential optimizations. The other thing we want to do is to say we're not going to go as far as the test number. We want to find out what the square root of the test number is. So the square root function comes from the math class, so math.sqrt, and into there we can put in our test number. that's going to return a double, and I just want to cast that to a primitive integer. So I think I can do this, and in fact let's store that as a number called max2check. And what I'm doing then is saying, well, if our test number is 11, max2check should now be 3, so we should be able to do is I less than max2check. Actually, for this it should be less than or equals to. So that's the second version. Now, I said that we expect that this second version should definitely be optimal compared to the first version, not just because of the primitives, but because we are running a loop far fewer times. But that's not definitely the case, because we're also now having to do a square root calculation, and we don't know that the square root won't take longer than the loop. So we absolutely want to test this and find out, is the second version, isPrime2, definitely more optimal in terms of performance than our first version.